Hello everyone, myself Dr. Varalakshmi K.R., working as Associate Professor in the Department of CSC, RL Developer Institute of Technology, Durgapur. So I continued with the previous session. In the previous session, just I was given an introduction about virtual circuit switching. As I mentioned, so in networking, we are going three approaches. So whereas this is the second approach where we are discussing on connection oriented. So this is one of the methods where we use in the data communication. So where here the path is a predefined, we say it as a logical. So it's nothing but an imaginary path. So that's why we call it as a shortly VC, that is the virtual circuit. So what is this virtual circuit? It is a path established between the sender and receiver before you're going to be data transmission begins. So the one advantage is here, all the packets travel along with the same path in order. This is the main highlight. It's almost similar to circuit switching. So but there the path is not dedicated. Here the path is virtual but not dedicated. So in a search, there is a few comparisons where I can compare with the datagram. So there here the packet sequence can be maintained, but there in a datagram approach, so we are not establishing any path before at data transfer. So some of the key features why we need an virtual circuit switching, because this is the main important concept where we use in a circuit deployment, especially if you go to the real time. So ATM is the best example where I can give asynchronous transfer mode where we are going to be using the deployment of the network. So the first feature is an connection oriented. Here, what is the meaning of a connection oriented? So where is the virtual path is established before your data transfer and a fixed path per session. So once the data packet session started, all the packets will follow the same route during the session and efficient resource use. So where the resources are shared, not reserved like in a circuit switching, and reliable deliver, this is the one highlight. So the packet sequence is maintained. So especially this we require in an voice or video transmission. So this is the main highlight where we require some of the important highlighted features in a virtual circuit. So let's go with an example. Let me take an how it works. So where the virtual circuit will be working in three phases. So the first phase is the setup phase. Here the path is established between the source and destination where the router and switches maintain a table for this connection. So the second phase is the data transfer phase. Once the connection set up, so the data will be forwarding based on the VCI table. So as I mentioned, as explained in the previous session, so VCI is nothing but a virtual circuit identifier. So instead of full destination address, what is this VCI table? So this will be just I will be explain in a further slide. And the third phase is an tear down phase. Once the session ends, the virtual path is dissolved. So this mantle is nothing but disconnected. So then we will take a few examples. So basically how it is going to be work. So here I taken imagine in a video call. So where we used to do, and if you, as I said, it is basically very good for voice or video transmission of the packets. So now this is the example I am taking. So let's imagine you are getting a video call. So between the two hosts, like a host A and host B. So here just I take a name of the person, Alice and Bob. So over in a virtual circuit, this is a virtual connection. So as we know that it will be going to be handled in three phases. The first phase is setup phase. So in a setup phase, the virtual path is connected between a host A and host B, where you imagine I'm connecting either the two routers or three switches named as the first one router 1, router 2 or router 3. So each router is going to be assigned an VCI to identify the path like a labels. So here the example router 1 with an VCI number 5. So the router 2 with an virtual circuit identifier number 12. So similarly router 2 with an VCI number 21. So this is the first setup phase. Then the second phase we are moving to a data transfer phase. Now, Alice wants to send a video data packet. See, instead of IP addresses, okay, packets are being tagged with an EJ. As already it's in the table, you can observe here path A to AB. So router 1, because initially we have the three which are routers in between the host A and host B. This is how the packets has been tagged with an R1 with an VCA 5, R2 with an VCA 12, R3 with an excuse me, VCA 21. So and finally, once the packets are moved, the last phase is tear down phase. So after the video call, so the virtual circuit is released and routers will delete the VCA mappings from the tables. So this is what the example scenario where I can give for how actually the virtual circuit works. As I mentioned, this is the best example in a real time, the protocol example where we are using in our ATM. So this will be working based on an virtual circuit switching, and similarly, the one more we call multi-protocol label switching. In the modern IP networks, we use the same similar principles. So till now we focus on two types of approaches we discussed. One is a datagram, another one is an virtual. So the datagram can also be called it as an connection less virtual circuit can also be called as connection oriented. Let's take a few differences between these two by taking a several feature. The first feature is connection setup. See, in a datagram, the connection setup is not required, whereas in a virtual, the connection setup is required. So the second feature is path. Here in a datagram, the path is variable, whereas in a virtual circuit, the path is fixed. So let's go to the third feature, packet order. Here the packet order is not guaranteed in a datagram where it will be maintained in a virtual circuit switching. So overhead per packet, it will be high because the full destination address where you want to be named in a header, whereas it will be low. So only because only VCI, that is a virtual circuit identifier, will be used. So it will be less burden overhead of the packet. So this is basically example. So where we are going to be handled the data. Let's go to, as we are telling VCA. So what is the format of this VCA table? What and all it consists? So here is an example. I have taken one topology example. Now host A to host B, just to look up how we can write an VCA table. So this is a setup example. Switch 1 and switch 2, we have two switches in between host A and host B. Let's say host A wants to communicate with the host B. So what is the first phase? We know that I need to set up in a circuit. So before going to be data transfer, so these are the fields of your VCA table. So the first field is nothing but a link, incoming VCI and outgoing VCI and outgoing port. Let's start with the first switch 1. So this will be manually set up by the network administrator. This is the number 20 is the outgoing VCA for the switch 1. So to where I should go to switch 2. So similarly, so 20 is outgoing for switch 1. So what is the incoming for switch 1? So the outgoing of switch 1 is incoming to switch 2. It is connected. The outgoing is 55. So where it has to go to host B. So this is just a simple scenario where I have taken just to make you understand how these will be transferred. Now I want to transfer the packet in this case. So before you transmitting the packet, this is what the topology where I have taken. So when host A wants to send a packet, it tags with the VCI 20. As I shown in the previous example, this is the VCI value I taken outgoing of an switch 2. So this is what the VCI 20. So what the switch 1 receives this VCI 20, then it will forward the packet to one switch 2. So it will keep the same VCI. So because the VCI never changed for the switch 1. So once the switch 1 receives its 20, then it takes its table and replaces this VCI 20 with an 50Y based on the table. So similarly in this example we have taken two switches, that is a switch 1 and switch 2. You can see the field. So these are the fields it is having, which is the incoming port. I need to start from the host A. It has to go to the next outgoing to which switch? To switch 2. What is outgoing? We see as an example we have taken 20. Now, similarly, here in a switch 2, we say table. So from which switch it is coming? From the switch 1 it is coming. What is the VCI? Previously it is 22. Which host it is going to host B? What is the outgoing interface value? 55. So because this is the 55 value, it has been taken in a previous example. So this is how you can see that the packet forwarding example. So in a virtual circuit switching. So basically these are the two approaches. So we are using datagram and virtual circuit, and here the another